Hello everyone. Here we have a hypothesis test for a population proportion. Okay, recall that to find point estimate of P, which is population proportion, we need to find x divided by n. So this P hat is point estimate or sample proportion. And the sampling distribution of P hat is approximately normal, provided that the following requirements are satisfied. So to have normally distributed, we should have all these three. The sample is a simple random sample. So the first part, we should have simple random sample. Then here n, sample size times p times q should be greater than or equal to 10. And the third one is that the sample values are independent. What that means, the sample size is less than or equal to 5% of population size. So this was sample size. And here was population size. Now here we have three methods for testing hypotheses. The first method is called classical or traditional approach. So that is the first method, traditional or classical method. Then second method is p-value approach. And the third one, using confidence interval. On this part, we're going to use p-value approach. So you're going to use second method. Okay, so on this part, hypothesis test using p-value approach, if the probability of getting sample proportion, so getting sample proportion as extreme or more extreme than the one obtained is small under the assumption of the statement in the null hypothesis is true, reject null hypothesis, so rejecting null. And what is convincing evidence? When observed results are unlikely under assumption that the null hypothesis is true, if this one is true, we say the result is statistically significant and we reject null. Okay, so here we have the definition for p-value is probability of observing a sample statistic as extreme or more extreme than one observed under the assumption that the statement in null hypothesis is true. I want to write this in. So using different words like, okay, a p-value is a probability associated with your critical value. And critical value depends on the probability you are allowing for a type 1 error. So that depends on For type 1, this was from previous section. And it measures the chance of getting results at least as strong as yours if the claim were true. What claim is null hypothesis. Okay, so it measures chance of getting results at least as strong as yours if the claim, or it's better to say this, null hypothesis were true. Okay, then okay, I want to add one more thing about that p-value. And what is the relationship between p-value and null hypothesis? The p-value is the evidence against a null hypothesis. Okay, now in this part we have test hypothesis about population proportion. So it's regarding population proportion showing with P. Here we're going to use steps 1 to 6. And first we should verify that we have these 3 steps from previous page. So we should have simple random sample, n times p times q greater than or equal to 10. And our sample values are independent of each other. What that means is n is less than or equal to 5% of population size. Okay, so step 1. So after that part, here we're going to follow these steps. Step 1 is that determine the null and alternative hypothesis. Exactly same as previous section, we have to tell, left tell, and right tell. What to tell was that when null hypothesis is equal to, so for all of these we have equal to. So since this one we're using, on this one we're going to use a population proportion, that's why on this part I have P. So P is equal to P0, that is our H0 or null. Here we have alternative. So on this part, since we have to tell, this is not equal to. Now in this part, left tell, when you have left, that means that here we have less than. And right tell, on this part, for alternative, we have greater than. Now step 2, we should select a level of significance, showing with A, I'm going to use alpha. So alpha, depending on seriousness of making a type 1 error. So that depends on type 1 error. Then step 3, compute the test statistic. And the formula for that part is 0 equal to sample proportion or point estimate minus what our claim was here for null hypothesis on that part. So minus P0 divided by square root of P0 times Q0 and divide by sample size n. Then step 4, determine what the p-value is. Okay, for total, we have what that is the sum of the area in the tills is the p-value. So adding area on this part, this part. So we're going to add these two. That is our p-value. This part, our p-value is area left of z, 0. So that is our z. And the area to the left is p-value. And for right, area to the right is our p-value. Then step 5, decide whether to reject the null hypothesis. If this p-value was less than alpha, what that alpha was, that was from step 2, significance. So if this p-value was less than alpha, then we should reject null hypothesis. So here we're going to reject H0. Then step 6, after you make your decision here, state the conclusion. Okay, so let me just again recall that what that p hat was. P hat was x divided by n. So this is point estimate of p, the population proportion. Okay, then next we have example related to that part. Test the hypothesis using the p-value approach. Be sure to verify what that means. We're gonna have these 3 steps here on top before starting these 6 steps. So first, we should verify this part. We should have simple random sample n times p times q greater than or equal to 10 and the sample size less than or equal to 5% of population size. Okay, so on this example, what we have null is population proportion is equal to 0.55, and alternative is that population proportion is less than 0.55. And n is 150, x is 78, and alpha is 0.1. Okay. So first verify those 3 steps. So first I should have simple random sample. I assume that we have one, we have random sample, and also these are independent. What that means, n is less than 5% of population size. Okay, so I assume that I have the first one and these are independent, so I have the third one. Now working on this part, n times p times q. I want to see if that is greater than or equal to 10 or not. So assuming that for n, working on number 3. So to verify, Okay, this is equal to N is 150. P0 is 0.55. And Q is 1 minus P, so it's 0.45. Okay, that is equal to 37.125. And this is greater than equal to 10. What that means, this is correct. Okay, the next step, test the hypothesis using p-value. Okay, so to test, step 1. Okay, let's go back there and what step 1 was. So step 1, I want to see which one I have. Do I have two tail, left tail, right tail? So here on this part we have null is, so always you have this part equal to. So P is equal to, P was 0.55. Now what alternative is that P, see, it's already given, P is less than. So we have left tailed. Okay, then step 2. We should find what alpha is. So that part is already given. So alpha is 0.1. Then step 3. We should test statistic. Using Z, so Z is equal to, here on top I use Z0. So let's use same thing. So Z0 is equal to, on top we have P hat minus P0 divided by square root of P0 times Q0 divided by N. Okay, so before writing that part, I need to find what P hat is. Okay, so finding P hat first. P hat is equal to X divided by N. X is 78 and N is 150. That's equal to 0.52. And I'm writing what P0 is. So P0 is given as 0.55 and Q0 is equal to 1 minus P0. So 1 minus 0.55. So that is 0.45. And here we're going to use N, so I'm writing N as 150. Okay, back to here. So on top, P hat is 0.52 minus P0 0.55 divided by P0 0.55 times Q 0.45 divided by n as 150. Okay, so then rounding this part, the answer is negative 0.74. Okay, so that was step 2. Step 3. Okay, then we're gonna work on step 4. Okay, here, step 4, we need to find p-value. So finding p-value, and this part we have left tail. Okay, what p-value is that? Finding probability of when z is, since this is left tail, z less than, from step 3 we have negative 0.74. Okay, using table, this is equal to 0.2296. So what we got that is, if I draw it, this is what we have. So z is negative 0.74, and the answer we got is for this part. So area or probability is equal to 0.2296. Okay, then step 5. We should compare p-value and alpha. If p-value was less than alpha, then that means that we should reject null hypothesis. So we should ask, is this p less than alpha? Or in other words, is for p-value we got 0.2296. Is that number less than alpha was 0.1? So is this less than 0.1? The answer is no. So based on our decision here in step 5, now step 6. What the conclusion is that we do not reject null hypothesis. So if this one was less than 0.1 and the answer for this part was yes, then we will reject null hypothesis. But the answer for p-value is not less than alpha, that's why we're not rejecting it. Okay, we finished example number 1. Okay, then example number 2. In December 2001, 38% of adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. Okay, so here we have 38%. In a recent poll, 403 of 1,122 adults. So we have these two numbers. With children under the age of 18 reported that the family ate dinner together 7 nights a week. As a proportion of families with children under the age of 18 who eat dinner together 7 nights a week decreased. Okay. We're going to use this alpha equal to 0.055%, and so that is our significance level. So it's asking if that one is decreasing. So first, we should have all those 3 requirements first. Some requirements. So again, assuming that this is random and we have independent. So assume we have simple random sample. And sample values are independent. What that means is n is less than 5% of population. So we have the first one, the third one, the second one was n times p0 times q0. So n times p times q greater than or equal to 10. Okay, what was given here? We had n equal to 1122. Then x was this one 403. P is 38%, so 0.38. And Q is 1 minus P0, so 1 minus 0.38 as 0.62. And finally, we're going to use p hat, so let's find p hat. So p hat is equal to x divided by n. 403 divided by 1122. And the answer is 0.359. So that is point estimate. Back to here. So n is 1122. P0 is 0.38, 38%. Q is 62%. So this is equal to 264.3. And this is greater than or equal to 10, so this is correct. Okay, now test. So exactly like this part, after we verified all these requirements, then we're gonna test. Starting with step 1. Okay, null is our population proportion is equal to P0, which is that one, 38%. Now what alternative is that? This P, since it's asking, okay, has a proportion of families, so proportion of families P, with children under age of 18 who eat dinner together 7 nights a week decreased, since I have this one, is decreased. What that means here, we're going to use less than. So P less than 38%. So that is step 1. Now step 2. You should find what the alpha is. So alpha is given as 5%. Then step 3, finding Z. Or test statistic. So Z is equal to P hat minus P0. P hat from this part we got 0.359 minus P0 is 38. So I have all these here is 38%. Divided by square root of P times Q divided by N. And N is 1122. So P is 38%, Q is 62%. Okay, then rounding that, the answer is negative 1.45. Okay, so this is our z-score. Okay, then step 4. Now we should find p-value. What that means, find probability when z is. Here again we have less than negative 1.45. So this is from step 3. Using table, the answer is 0.0735. Okay, I'm rounding it to 0.07. So what that means, here again, if I draw it, that is the area for left tail. So Z is negative 1.45. And area is equal to, okay, since I rounded, okay, let's use that, is 0.07, is that part. Okay, so we finished step 4, now step 5. Okay, step 5 now, we should compare p-value in alpha. So is p-value less than alpha? So is 0.07 less than, or alpha was 0.05, 5%. Is that one less than 5%? No. So that is step 5. Now based on our decision here in step 5, now step 6. Conclusion is that we do not reject this null hypothesis. I'll write this in Word, what that means. That means that there is not sufficient evidence to conclude that the proportion of families with children we together has decreased. And that was since December 2001. Summarizing what I wrote here is that, okay, exactly same as example number 1 on this part. We do not reject null hypothesis. Here on test, you don't need to write all this, just write this part that you're rejecting this null or not. Okay, I finished this example. We have one more. Okay, example number 3. In 1994, 52% of parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. Recent survey found that 256 we have that's 52%, 256 of 800 parents of children high school felt it was a serious problem that high school students were not being taught enough math and science. Do parents feel differently today than they did in 1994? This part here again is given as 5%. That is alpha, level of significance. Okay, so I'm writing what was given here first. So n is 800. X is 256. Then P0 is 52%. Now using this P0, finding Q0 as 1 minus 0.52% is 48%. Okay, now finding P hat, point estimate, X divided by N. 256 divided by 800. So that is 0.32. Okay, then you should have all those three requirements. Here again, we're assuming that this is random and independent. Assume that our sample was random and independent, but that means n less than 5% of population. And also n times p times q, this should be greater than or equal to 10. N is 800, p 52%, q 48%. Okay, this one is 200, which is greater than or equal to 10. So that is correct. Now testing. Again, starting with step 1. What we have for null hypothesis and what is alternative. Okay, so this p is equal to 52%. It's asking, do parents feel differently today? So it's not saying any decrease, increase, greater than, less than. So it's just saying, do they feel differently today? What that means here, we're gonna have is not equal to, because they may feel differently. So it's not equal to 52%. So this is alternative. Now step 2. What alpha is given as 5%. Okay, step 3. Finding z. On top we had difference between this point estimate and p0 denominator, square root of p times q divided by n. Okay, p hat was 32%. And here we had 52% divided by square root of 0.52 times q divided by n as 800. Okay, rounding this, we have negative 11.32. Okay, then step 4. Finding p-value. Okay, how we can find p-value for this part, because we don't have greater than and less than, we have is not equal to. Well, that means we have to tell test. So this part to tell. So we should find either tell, so right or left, and multiply the result by 2. Okay, so probably that either one works. So here I'm trying when z is less than, so this is left till negative 11.32, and that is equal to 0. Why I'm using that positive? Because this number means this number is so small, and that is so close to 0, so it's so small. How I know that this is equal to a small number? Okay, using our table. Okay, we have negative z-score. Okay, this is z equal to negative 3.4. See, we have negative 3.49. It's this number. And for negative 3.39, we have this number. So this is less than that one. If you go up and having a negative 11.32, then the number that you're gonna see here will be not exactly like that, but like this. So that's why instead of having that kind of number, we're using 0 plus, showing that the number is very small. And if you round it to 4 decimal places, you're gonna have that equal to 0. This is true for also when you have positive z-score. Okay. See, here we have this 3.49. We have 0.9998 when it's increasing, like, okay, for example, 11.32. Now I have positive. Then you're gonna have 0.9999. 3.99 is like that, so it's getting closer to 1. So this part, the positive z-scores, when you're increasing that z-score, it's getting closer to 1. And for negative z-score, when you're increasing that one, so actually this is smaller. So when you have negative numbers, this getting smaller based on what you have on number line. That's why the probability for that also is decreasing. It's getting closer to 0. Okay, so p-value is close to 0 after multiplying by 2. Same answer. So 2 times. That is again same answer. Okay, so that was step 4. Now step 5. is p-value less than alpha. So is this number less than 5%? Yes. Okay, so now conclusion. There is sufficient evidence to reject what that means. We reject null hypothesis. Okay, I finished this part. Okay, hope you enjoy this. Bye-bye.